Hi all, welcome to my channel. So now we can see another problem of this internal hinge. So this type of this problem is very important for almost all the examinations, including GATE, ESE and State Government Assistant Engineering examination, next is ISR. So almost all examination this type of problems is very important. Okay, so this is so let's see how we can do this. Here it is, and there is an internal hinge. Here it is an internal hinge. So this is, let's see, a distance of 2 and 4 and 2. Okay, so there is an internal hinge like this. It is A and D. Okay, so let's find the shear force, bending moment, and next we can draw the shear force diagram as well as bending moment diagram. Okay, so let's see. Okay, so let's find it. So first we can, in this internal hinge, let's separate this as two beams, that is AC, beam AC, and next one is this is CD. So we can separate this, and here what will be acting at C, there will be a reaction, and here there is, because of this, there is a reaction called RB. Okay, so this is RB. So here it is 4 and here it is 5. And what will be this load acting at this point? Okay, so this point load acting at the point which is, okay, so here it will be, so okay, so it at center it will be acting, so 4 5 6 7 8. So center it will be acting, so this is 200. Here we can see 200. If this load is at this here, okay, so here if this load is acting as point load, then we will convert this UDL to point loaded. If convert to point load, here it will be acting at this point. So 200 into 4 plus 2 is what? So 200 into 4 plus 2 is 6. So 200 into 6 at a distance of what? At a distance of this 3 it will be acting. Okay, so okay, let's find it. Okay, next, but here from this point C, entire load is what? 4 plus 2, it is 6. So while convert this, okay, so we have taken this ABC, so ABC. So while converting this as point load from this UDL, so 200 into what? 200 into 6, but it is acting at the centroid. So it will be the centroid will be this 3. That is 6 divided by 2, it is 3. Okay, let's find these reactions. So here what RB, so upward force equal to downward force while considering this equilibrium. So what we'll be getting? So RB plus RC equal to, so downward it is what? 1200. So next, while considering this moment at C, taking this moment at C, so RB into 4. So clockwise moment RB into 4 equal to what? We get this anti-clockwise moment. So anti-clockwise moment, it is 200 into 6, which acts as a centroid of 3. So 200 into 6 into 3. So we will be getting this RB as 900, and while substituting this RB here, we will be getting this RC as 300. Okay, let's find. So for RC also, so that is for this CD, just CD, it is at a distance of this 2 and the load is acting, that is your UDL load. And if we consider this RC, we have already found this RC equal to 300, and there is a reaction of this RD here, as well as there is a moment, because here it is fixed. So what we will be getting this MD. Okay, then what we want to find is, then just note down here this RC is downward and here it is upward. So both are having RC, but why it is having this different magnitude? One is upward and one is downward. So what happening is, this RC will try to bring back, so this CD will push this, so push this AB into upward direction, and this CD will pull this AB in downward direction. So that is why it is having this reaction like this. So let's find this moment. So this, if we convert to this point load, so 200 into what? So 200 into 2 is nothing but it is 400. So while considering this moment at this T, what we will be getting? So clockwise moment equal to anti-clockwise moment. So if we consider this clockwise and anti-clockwise moment, so this is 300 into 2. So this is clockwise and this is anti-clockwise. So 300 into 2 and another point load. So while converting this to point load, so we'll be getting 200 into 2. So that is 400 into centroid of this what? 1. So plus what? 400 into 1 equal to M. So what will be the M? After solving, we will be getting 1000 Newton meter. Okay, next we can see we didn't find this RD. Okay, so RD, for finding this RD, upward force equal to what? Downward force. So RC is downward force, that is 300, equal to the upward force what? Here it is downward force, that is downward force 300 equal to upward force what? 400. 400 means here it is 400. So upward force 400. So 400 we will be plusing that. So this is RD. So this is RC plus 400. So RD equal to what? 700. So we got all the reactions. In almost all the competitive examinations, they will be asking this reactions to find this reactions. So they will be asked to find this internal hinge reaction. So this is asked in almost all the competitive examinations instead of drawing the shear force diagram and bending moment diagram. So after finding this, what we will get? There is no internal moment. So there is no moment present in this internal hinge. Okay, let's do the shear force diagram. So here we have seen, and let's do the shear force diagram. So at A, the shear force is what? 0. So at A, it will be 0 because while considering this LHS and RHS, what we'll be getting? So 0. There is no load before and after because it is summation of the lateral loads, right? So there is no load. So it will be 0. And okay, so while going this like this, at this point, what is happening? At this point, okay, at this point, before what is before this RB, before 900, what is happening before 900? There is it will be, that is UDL, it will be 200 into 2, that is minus 400 it will be. So we can draw this minus 400 and there will be a reaction of this 900. So minus 400 plus 900 is what? Here you will be getting 500. Okay, we have drawn this 500. Next, at this point C, there is no vertical reaction, so there is no need to find all these things, so don't consider all this vertical slip and all. But before that, what will be the load? Before that, what will be the load? 900 will be there, and this is 200 into what? 6. So I'll be fine. I'll just write it. So I'd see what will be. So this is minus 200 into 6 because it is acting downward. So minus 200 into, so this is 4 plus 2, it is 6. So minus 200 into 4 plus 2, that is 6, plus what? Plus this reaction, it is 900. So you will get an answer of about minus 300. So you want to write this minus 300. So first join this A to C like this, next vertical, next join like this. Okay, next what we want to find is, we want to find the shear force at C. For finding the shear force at for shear force at D, it is very easy to find if you find from this RHS. So RHS, what is the load? It is 700, as it is from by finding from this RHS. So firstly we want to put this minus and summation of this lateral loads. So while considering this RHS, what is happening? Only 700 is there, so minus 700. Or if you are finding from this LHS, how you can do? So what will be the load? So minus 200. So minus, it is acting downward, so minus 200 into 2 plus 4 plus 2, that is 8. So 200 into 8 is nothing but it is 1600, plus upward force, it is 900. Or you can do is what? Minus 6600 plus 900. There also you will get minus 700. Okay, so we can just join this. So shear force diagram is over. Next, what we want to do? Bending moment diagram. So here there is no moment, right? So as here it is, there is no moment. We must find the, so this point is what? So we, here the point is here. Okay, here it is X. So here the shear force sign is changing from this positive to negative. So assume this as the distance X. We want to find this distance X. Here what it will be? So if it is total 4, so 4 minus X, it will be 4 minus X. So here theta, here theta. We have already done this type of problem in previous sum. So previous, just look that video, you will know how we have solved this. We will be getting it. So while solving this, what you get is, so I'll write here. So here this is 500 divided by x. So 500 divided by x equal to 300 divided by 4 minus x. So 300 divided by 4 minus x. Next we can see, so this is x equal to 2.5. We got x equal to 2.5. The shear force will be 0. Okay. Next we want to find this what? Bending moment. So I can find this bending moment at this place. So without looking, we can see for x equal to 0, the bending moment is what? 0. Okay, we have found this m at this moment at this x equal to 0 is 0. Next, what we want to find this moment at this x equal to 2. X equal to 2, what is happening? X equal to 2, at 2, there will be a UDL only, and at a reaction, so at the center also 200 into 2, while converting this UDL to point load, so 200 into 2 into it is acting at this 1. That is 200 into 2 into 2 by 1. So what you will be getting? It is acting here. It will be putting this minus symbol. Why minus symbol? Because downward the force is acting. So minus 400. Next is what this m at x equal to. So this we got it as 2.5. Here it is 2. So total here it is 4.5. So m at this moment at this x equal to. So this is 4.5. What will be the moment at x equal to 4.5? The moment is what? Moment will be Okay, so till here, first we want to convert this UDL to this point load. So 200 into 4.5 into this is centroid. So what 200 into 4.5 into 4.5 divided by 2. Next is reaction, that is RB, which is acting upward. So plus 900 into what? 900 into this distance, that is 2.5. So 900 into 2.5. So here what we will be getting, so as 200 into 4.5, this is downward direction. So put the minus symbol here. So what we will be getting, we will be getting this 225. Okay, so we will be getting this 225. Okay, so we will be getting this 225. Next, this is m at this x equal to 6, x equal to 6 what? X equal to 6, that is 2 plus 4. At Hinge, the there is no moment, so 0. Next, m at this x equal to 8, that is still here, there is only this moment is happening, that is 1000. So this try to what? So this try to, there will be a what hogging will be happening. So at this hogging, what it is minus 1000. Okay, next let's draw this bending moment diagram. Okay, so we have just, I have just noted all these points at x0. Okay, so I have just, okay, so x equal to 2.5 for this bending moment, m x equal to 0, and x equal to what? For this x equal to 6, it is here, and it is this 1000, and x equal to this is 12, it is minus 400, and this is 225. So these are the some moments. So we got these moments after just plotting these points. So next we know that we want to join this. So what it will be? It will be definitely parabola, because it is linear, so it will be parabola. Shear force diagram is linear, so it will be parabolic. So how to draw this parabolic? First is, so as the shear force is 0, the what will be? It will be horizontal line, because of the slope will be what? Slope will be minimum or 0. Next here this maximum shear force is there, but look here it is 0 shear force. So for the shear force it is what? Maximum or minimum? It is minimum, so slope will be minimum of 0, so it is horizontal line. Next here what is happening? Here maximum shear force vertical line, here also maximum shear force vertical line, and here what is happening? Here this 0 shear, here what is happening? Here the shear force is what? Here maximum only. So next to join all this as parabolic. Okay, join this as parabolic. Wow, I got this. Join this. Okay, we got the shear force and bending moment diagram of this, but in examinations they will ask you to find the reactions of this internal hinges. Mostly in all the competitive examination they will ask this type of questions. Thank you.